Example 4, find two positive numbers that satisfy the given requirements. The product is 185 and the sum is a minimum. So again, this is one of these optimization problems where we're trying to find a relative extrema. Here it's going to be a relative minimum because that's what it states in the problem. Here it says the product is 185 of two positive numbers. So let one number be x, another number be y. If you take the product of those numbers, it's going to be 185. It also says the sum, so x plus y, is a minimum. This is what we are optimizing. We want to find a relative minimum value. To do that, the first thing we're going to do, we're going to write y in terms of x. So I'm going to solve for y here, divide both sides by x. I'm going to get 185 over x. So this is going to be m of x equals x plus, and I'll rewrite this as 185 x to the negative first because I'm going to have to take the derivative of it to find the critical numbers. Remember, the relative extremas are going to happen at the critical numbers, and we want the one that is a minimum. So I'm going to take the first derivative, so m prime of x equals, the derivative of x is 1. The derivative of 185 x to the negative first would be negative 185 x to the negative second. And now we need to find the critical numbers. So to find the critical numbers, we're going to set the derivative equal to 0. We're also going to find the x values where this derivative does not exist. So if I move the negative 185x to the negative second power to the other side, this would become positive 185x to the negative second equals 1. Then I can rewrite this as 185 over x squared equals 1 to take care of that negative exponent. Then I can cross multiply here and get x squared equals 185. Then I can square root both sides to get x equals plus or minus the square root of 185. And I have to throw the negative one out because it says the values are positive, right? Find two positive numbers. So one of the numbers potentially could be x. It's got to be positive. Also, let's see. If we think of this as being 1 minus 185 over x squared, the number here, x, if x is 0, the derivative would not exist. Again, so this is a possibility, except that the values have to be positive, so we're going to throw that one out as well. So now we just need to figure out from 0 to infinity, we've got the square root of 185. We need to use calculus to show that that is a minimum. Easiest way to do this is the second derivative test to show concavity. If this is concave up, then this would have to be a minimum at x equals the square root of 85. So let's find the second derivative. So the derivative of 1 is 0. The derivative of negative 185 x to the negative second would be positive 370 x to the negative third, or 370 x cubed. And then we need to do this. We need to do m double prime of the square root of 185. See if this is positive, negative, or equal to 0. Well, if you plug in the square root of 185 here and cube it, this is all still going to be positive. So this is going to be greater than 0, which means concaved up, which means relative min at x equals the square root of 185. And then we just have to find the y value. To find the y value, you're going to plug that in here. X is the square root of 185 times y equals 185. Divide both sides by the square root of 185. Multiply by the square root of 185, the numerator and the denominator. The numerator would become 185 times the square root of 185. The denominator would become 185. These would cancel out, and y would also equal the square root of 185. So that would be the two positive numbers that satisfy the given requirements.